So okay, so welcome to all of you. Now we will see Newton's forward difference interpolation formula. So there are two formulas: Newton's backward difference interpolation formula. Also there one more interpolation formula is there, that is Lagrange's interpolation formula. So these are the three interpolation formulae: forward Newton's forward interpolation formula, and backward interpolation formula, and Lagrange's interpolation formula. Okay, so we'll see first Newton's forward difference interpolation formula. Okay, so this is also very useful in the numerical analysis. So what we will do? So let y is equal to f of x be a function which is defined on closed interval x0 to xn. So what we will do? We will divide the interval x1, x0, xn into n sub equal intervals. Okay, each of length is h now. So suppose these are the intervals x, x1, x1, x2, dot dot dot, xn, xn minus 1. These are the n. So this is 1, 2 up to n. These are the n such intervals. Okay, so whose length is h. So that means what? xr is same as x0 plus h, where I is 0. That means what? x0 is x0, x1 is same as x0 plus h, x2 is same as x0 plus twice h, and so on. xn is same as x0 plus nh now. Okay, x0 is same as xn is same as x0 plus nh now. So suppose that f of x is a single valued function. Okay, and it is continued on the closed interval x0 to xn, x0 xn now. So let y0, so y0, so value of f at x0 is y0, value of f at x1 is y1, and so on. So y is equal to f of xn. Okay, so now we want to obtain a polynomial. So here we have to obtain a polynomial yn of x of degree n. So instead of yn of x, so what we will see? F of x now. Okay, no problem if you say f of x. Okay, instead of y we will write f of xn. Okay, f of x of degree n such that y and yn agree with the tabulated values. Okay, so let y this f of x, we will say f of x, this is f of x, be a polynomial of nth degree such as so we'll write a polynomial here, so that I want that polynomial, so we'll write that f of x is here now. Okay, so f of x a0 plus this is a1 x minus x0 plus a2 x minus x0 x minus x1. Okay, so these are two products. So we'll write a3 x minus x0 x minus x1 x minus x2. Okay, so plus dot 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 plus an x minus x0 x minus x1 x minus x2 dot dot dot. This is what then last one is what? X minus xn minus 1. Last one will be, because there are n. So this is started from 0, 1 to n minus 1. So this will be n product. Okay, so I call this as 1. I will call this as 1. So what I want to find the values of a0, a1, a2 up to an, where a0, a1, a2 dot 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 an are constants, to be calculated as f of x0 is equal to y0, f of x1 is equal to y1 dot dot dot, f of xn is same as yn. Okay, so put x is equal to x0 in 1, we'll put x is equal to x0 in 1. Okay, so we'll put x is equal to x0. So what do we get then? F of x0 is equal to a0. So this is y0 then, because f of x0 is same as y0. Okay, so therefore a is equal to y0. So you get the values of a as a y0. Okay, So we put a naught as y naught. So now we want to find the value of a1 now. So put x is equal to x1 in 1 we get. We put x is equal to x0 we get. What we get then? F of x1. F of x1. So a naught will be as it is. A naught will be as it is. Plus a1. So we are putting x is equal to this. So x1 minus x0. X1 minus x0. Okay. So this is what then? This is y naught. Oh, this is y1. No, this is not y0. This is y1. This is y1. So your a naught is y0. Plus a1 you want. A1 you want. And x1 minus x0 is h now. This will be h. Right? X1 minus x0. See, this is the interval difference. X0, x1. So this is what? So interval difference is h now here. They are equal space. Your values of x are equal space. So this is the interval difference. X2 minus x1. X2 minus x1. This is h now. This is h. So this is h. So you want a1 now. So a1 is what? Just y1 minus y0 upon h. Upon h. So this is what then? 1 by h. 1 by h. This is what? Delta y0. So your a1 is what? Delta y0. So I will write this value a. This is a0. A0 is y0. A1 is 1 upon h delta y0. Okay. So for my convenience, I have I have written the value a1 to that side, so that I have to put the values of a0, a1. So here, so that I will get the formula for Newton's forward interpolation formula. If you find the values of a1, a0, a1, a2, find the values of a0, a1, a2, put there. That will be your Newton forward interpolation formula. Okay. So now put x is equal to x2 in 1 we get. Okay. So we'll find up to this. Okay, and we'll generalize this. Okay. So we'll find this. We'll find only this a2 and we'll generalize a3, so that we'll generalize the other a. Okay. So at least you find a0, a1, a2. Okay. And by just generalize and write the direct value of this a3 and so on. Okay. So we'll find this. Put x is equal to x2. So this will be what then? F of x2. F of x2. This is a0 as it is now. Plus a1. Just write a1 as it is now. So this is what? X minus x. X1. You have to write what? X2 now. So x2 minus x0. X2 minus x0. Plus a2. Plus a2. X2 minus x0. X2 minus x1. X1. Okay. So what is this? This is your y2. So your a0 is y0. That is known to you. So now your a1. So I will write this value of a1 is this. So this is what? A1. This is plus. Plus. Value of a1 is what? Y1 minus y0. Y1 minus y0. Just I write this neatly. Because what? If I made mistake here, then problem will be arise. Okay? Upon h. Y1 minus y0 upon h. So x2 minus x0 is twice h now. X2 minus x0. Because what here? So this is x0. This is x1. This is x2. This is h. This is h. Right? So up to this is what? This is twice h now. This is what? Twice h. So x2 minus x0 will be the twice h. Okay? Plus I want a2 now. This is twice h now. x2 minus x0 is twice h. And this x2 minus x1 will be h now only. It will be h only. Okay? Now this h get cancelled. This is what? Y2, y0 plus. So what is this? H get cancelled. This is 2 times y1 minus y0 plus twice h square a2 now. Twice h square a2. So what? I will shift to this that side. So what I got? So this is what? Twice h square a2 is equal to what? So what will I do? Okay. Okay. So I have written this. I have shifted this to, but I am writing here what? Y2 minus twice y1. I have shifted this. So this is what? Minus. This is plus y0 now. This is plus y0. And we know that this is nothing but del square y0. Just we have calculated this. See, what is del y0? Del y0 is what? y1 minus y0. Okay, what is del square y0? Del square y0 is what? Del y1 minus y0. Okay, so that is what? Increase the suffix by 1. So this will what? y2 minus y1 minus this will be as it is now. So what is this? This is y2 minus twice y1 plus y0. So see, we get this y2 minus twice y1 plus y0. So this is del square. So this is what? a2 is equal to 1 upon 2 x square del square y0. Okay, so I can write this is what? 1 upon 2 factorial h cube del y0. 2 factorial. So I will check whether this is work or not. So I write here. So a2 is equal to 1 half 2 factorial h square del square y0. Del square y0. Okay. Now without that, so I will directly say this one what? So similarly I will say. Okay. Similarly, just I will say here what? Similarly. Very easy formula now here. Only I have to do this one. You have to find the values of a0, a1, a2, and easily we will say now here what? Similarly, just we will write here what? Similarly, we can prove a3 is equal to 1 upon 3 factorial h cube del cube y0 dot 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 an is equal to 1 upon n factorial h cube del to the power n y0. Okay, put the values of a0, a1 dot dot an in 1 we get. So we put the values of a0, so we get. So we put the values of this in 1. What we get then? We put the value of this. This will be your f of x. A0 is what? Y0. Plus a1 is 1 upon, so this is what? Delta y0 upon h x minus x0 plus 1 upon 2 factorial h square del square y0 x minus x0 x minus x1 plus a3 1 upon 3 factorial h cube del cube y0 x minus x0 x minus x0 x minus x1 x minus x2 plus dot 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 plus 1 upon n factorial h raised to n 10 to the power n y0 x minus x0 x minus x1 x minus x2 dot dot x minus n minus. I will call this as 2 now. I will call this as 2. Okay. Put. So this is what? This is the Newton's interpolation formula. This is okay now. But to solve the problems, this is very difficult to remember this. Okay. So we'll make a simple formula of this by putting this. Put x is equal to x0. Put x is equal to x0 plus ph. x0 plus ph. x0 plus ph. So what do we get then? So this implies that x minus x0 is equal to pH. X minus x0 is pH. Okay. Then x minus x1. X minus x1. So this is what? X minus. What is the x1? What is this x1 then? Okay. So you see this is what xi is equal to so we have x0 plus ih now. Okay. So now your x1 is equal x0 plus h. Your x0 is what? x1 plus h. So I will write here. See, this is your x minus x0 is ph now. Okay. I have to write x minus x1 then. X minus x1. So x minus x1. So your x is what? x0 plus ph minus your x1 is what? x0 plus h. x0 plus h. Right? x0 plus h. So this will what then? x0 get cancelled. x0 get cancelled. So p minus 1 times h. Okay. X minus x1 is what? P minus 1 times h. Okay. So I will replace this x minus x1 as p minus 1 times h now. Okay. So what happened then? X minus x2 then? X minus x2. So x is what? x0 plus ph. Okay. So x2 means what? x2 is what? x0 plus twice h. x0 plus twice h. So I write this what? x0 plus twice h. This is minus. Okay. So what is this then? x0 get cancelled, and this is what? P minus 2 times h. X minus x2 will be what? X minus x2 will be what? 2 p minus 2 times h. Okay. So put x is equal to x0. So this is what? Okay. So this what? X minus x0 is, we get this one. Okay. We get this. So therefore, so x minus x n minus 1 is equal to what? P minus n minus 1 times h. So that means what? So we write this. So this is same as what? P minus n plus 1 times h. P minus n plus 1 times h. Okay. So we write here now. So what we get then? So f of what is this? X is what? x0 plus ph. This is very important. Huh? x0 plus ph is equal to, I can write that f of x, no problem for this one. Okay. So now y0 will be as it is now. This y0 will be as it is. So this is what? Del y0 upon h now. X minus x0 is ph now. This is what? ph. I write here. Plus 1 upon 2 factorial h square. Del square y0 will be as it is. So now this is what? X minus x0 is what? X minus x0 is ph. So I write this ph here. So this is ph. Okay. X minus x1 just I have calculated. This is what? P minus 1 times h. Okay. So plus 1 upon 3 factorial h cube del cube y0. Just I have calculated this. Okay. What is x minus x0? X minus x0 is ph. Then this is what? P minus 1h. Then this is what? P minus 2h now. X minus x2 is what? P minus 2h. Okay. So plus dot 1 upon n factorial h to the power n, del to the power n y0. Del to the power n y0. So then this is what? ph. P minus 1 times h. P minus 2 times h. Dot. P minus n plus 1 times h. Okay. Now this is very simple now. So what we get then? This is what? F of x0 plus ph is. X0 means starting value. X0 means starting value. H means the interval difference. Okay, and now we have to find only the value of P now here. So this is what then? This is what? Y naught plus, now this is H get cancelled. So this is what then? P times del Y naught. P times del Y naught. Then this is what then? H square. This is H into H is H square. H square get cancelled. So this is what? Plus 1 upon 2 factorial P into P minus 1 del square Y naught. Right? Plus, now this is H cube. So this is, there are 3 H get cancelled. So this will what then? 1 upon 3 factorial P minus 1 P minus 2 del cube Y naught plus dot plus 1 upon n factorial P minus 1 P minus 2 dot P minus n plus 1 then to the power n Y naught. Okay, so this is called Newton's forward difference interpolation formula. Okay, so no need to write this. What? Just will write this is what? Newton's simple forward difference interpolation formula, because this is not a title formula. Okay, so this is very important, right? So remember this, f of x naught plus ph. Just you must have to remember this. If you want to solve the problem by using Newton's forward interpolation formula, you need this formula. Okay, so remember this formula to find. Suppose what we have given the values of like this. So 2, 3, 4, 5. Suppose these are the values of x. So x, the values of x should be the equal space. If the values of x are not equal space, you cannot apply the Newton's forward interpolation formula. Note that. Okay. What are the value? This is what, suppose 7, 9, 5. This is what 18. Suppose there is a function. There is a function such way that the values are this. Okay. So now this is your y naught. This is your y1, this is your y2, this is your y3, and this is your y4. Okay. So what you have to do? You have to prepare a difference table, forward difference table. So you have to prepare a difference table, and you have to write the values of delta y naught. So y naught is what? 7. Then what? So this minus this will be your delta y naught. Okay. So then you have to prepare the difference table. You have to prepare a difference table, and you have to see how many values are there. 1, 2, 3, 4, 5 values are there. So you have to write this formula up to 10 to the power 4 only. In problem, so this is the general formula, right? But in problems you have to write the full formula, right? Depending on the 10 to the power 5 or 6 or this, depending on the data now. Okay. So here what 10 to the power 5 is a 0 now here. So this is what 1, 2, 3, 4, 5. So you have to write this formula up to 10 to the power 5 only. Okay. So I hope that you understand how to prove the Newton's, how to create. So this is the expression, how to express the Newton's forward interpolation formula. This is the proof of this one. Okay. So this is the statement of the Newton's forward interpolation formula. So if question asks like this, state and prove the Newton's forward interpolation formula, just write this one. Just for this what? This is the Newton's forward difference interpolation formula. No need to write the statement. So directly write all those things up to this. Okay, up to this you have to write all those things, right? That is the proof of statement and the proof of the Newton's forward interpolation formula. So we have expressed here the Newton's forward difference interpolation formula here. So now in the next we will see how to develop the Newton's backward difference interpolation formula. Okay. So now just go through this 2 or 3 times. Independently you should write this statement and the proof of the forward difference, Newton's forward difference interpolation formula. Okay. So now we'll stop here.